Hey there, I'm making this video as a response to a synchronous learning experience that occurred with my virtual class during the COVID epidemic, in which I completely botched the presentation for both hours, I think. So I would like some redemption, and the topic of this video is the classification of matter in chemistry class. So matter can be broken down into two broad categories. We have pure substances and mixtures. An example of a pure substance is an element, which contains atoms of only one kind. And another example of a pure substance is a compound, which contains atoms of more than one kind, chemically bonded together. An element cannot be broken down into any simpler substances, chemically or physically, and a compound cannot be broken down into any new substances chemically or physically, but it can be broken down chemically, as these can be separated. This will be discussed in more detail coming up, so it's not that important that you write it down or anything like that right now. Mixtures can be categorized as homogeneous or heterogeneous, and it's essentially on how well it's mixed up. So a homogeneous mixture is very uniform in composition, and a heterogeneous mixture is chunky. So a pure substance is a type of matter with a fixed composition by mass. Every sample has exactly the same characteristics, properties, and composition. And the examples, as mentioned before, include elements and compounds. So we'll talk about elements first. I don't know why this is doing this. We'll see how many times it does it. There we go. Elements, the definition of an element is it's made of only one kind of atom. And an atom, by definition, is the smallest unit of an element that retains the properties of that element. Elements, again, cannot be broken down physically or chemically into a simpler substance. The formula for carbon is C. The formula for copper is Cu. The formula for iron is Fe. And the formula for sulfur is S8. And we will talk a little bit about why this one has a number and the other ones do not. So some symbols originate from Latin names. For example, copper used to be called cuprum, and iron used to be called ferrum. And in some places it's still called that. Latin and Greek names is what was originated. So most of the time, the element symbols are just what the periodic table says, but there are 7 special elements that are referred to as diatomic elements. And those include hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Coincidentally, on the periodic table, they kind of make the shape of a 7. 2 elements are considered polyatomic elements. One is sulfur, and it has a formula of S8. That means that a molecule of sulfur is composed of 8 sulfur atoms. 1, 2, 3, 4, 5, 6, 7, all linked together. And phosphorus is P4. There are 4 phosphorus atoms linked together. With hydrogen, which is diatomic, hydrogen has 2 hydrogen atoms linked together as a hydrogen molecule, as does nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Well, I guess we get to see this a bunch of times too. I don't know what's happening. Here are some examples of elements. This is carbon, and these are called allotropes. Allotropes are different forms of the same element. And they have different properties because their atoms, the atoms are arranged different. So carbon is diamond, and it's also graphite. And they have, this is one of the hardest substances known that is naturally occurring, and graphite is very, very soft. Here are some allotropes of sulfur, which we may or may not get to see in the lab. One allotrope has very blocky crystals, and one has needle-like crystals. So a compound is made from atoms of two or more elements that are chemically bonded, and they may be broken down by chemical means. The molecule is the smallest unit of the compound that retains the properties of that compound. Here are some examples. Water is H2O. Carbon dioxide is CO2. Iron 3 oxide is Fe2O3. Copper 2 carbonate is Cu, CO3. And sulfur dioxide is SO2. Here are water molecules. This is some copper carbonate here, CuCO3. This happens to be some iron 3 oxide, Fe2O3, and this is smog, which is a sulfur dioxide, is one of the main ingredients in that. Here's some water. Water is H2O, and you can see that it occurs in different ways, as a liquid, as a solid, and as a gas. And that's another discussion, is how the molecules are arranged in the solid, liquid, and gaseous state. So we talked about elements and we talked about compounds. Now we're going to talk about a homogeneous versus a heterogeneous mixture. So by definition, a mixture contains more than one substance, and it can usually be physically separated. Each component retains its own identity and properties. And we have two types of mixtures. One type is called homogeneous. It has a uniform composition throughout, not chunky. It looks the same throughout. And a homogeneous mixture can be a solid mixture, a liquid mixture, or a gas mixture. Another name for homogeneous mixtures is solutions. So solutions can be solid, which include metal alloys. I will show some examples of that in this upcoming presentation. Liquids, like if we were to dissolve salt in water, or gaseous, which is like the air that we are breathing. A heterogeneous mixture is not uniform, and it is chunky. Now this goes down to the molecular level. If we were to look at a mixture under a microscope and see chunks, a homogeneous mixture will not be chunky. So even on a microscopic level, it would all still look uniform. So here is some air. Air is a homogeneous mixture. It is also known as a solution, and it contains some nitrogen, oxygen, carbon dioxide, water vapor, and lots of other things. The air in a room where lots of people have been breathing is probably going to be more rich in carbon dioxide than it will be in oxygen at the end of the hour compared to the beginning of the hour, because of people breathing. Here's a liquid solution of things dissolved in water, most likely. Lipstick looks uniform throughout, and this is brass. Brass is an alloy, and it contains copper atoms and zinc atoms. And I have a picture coming up that will show you perhaps how those get mixed together and what they might look like at the molecular level. So here is some heterogeneous mixtures, and these are chunky. Oftentimes you can very easily mechanically separate these parts. Here's a magnetic substance being separated from a non-magnetic substance. Here we have some magnetic iron, and here's some sulfur. We can also physically separate these two. If you were to melt the brass, the zinc would start melting first, and you could extract it, and the copper would remain. There are also ways to physically separate out the elements and compounds from air as well. here's some granite. It's heterogeneous. Blood, I'm not sure where all these came from. Blood is actually a heterogeneous mixture because if we were to look at it at a microscope, we would see red blood cells and white blood cells and platelets and plasma. Copper 2 sulfate is a homogeneous mixture, which is also known as a solution. So a reminder that compounds can be broken down chemically into simpler substances. So water is a compound and it can be broken down chemically, but it cannot be physically separated. Here is a summary slide of everything again. If the matter is made of only one kind of atom or molecule, like water or helium, then it's a pure substance. Pure substances can be broken down into elements and compounds. If we have a mixture, because there's more than one kind of atom or molecule, if it's uniform in composition, it is homogeneous. And if it is chunky or non-uniform in composition, it is a heterogeneous mixture. So here is another molecular view, atoms of the same element. This would likely be a gas based on how far apart the particles are. This is a diatomic element. It could be hydrogen or nitrogen or oxygen, fluorine, chlorine, bromine. You see the two atoms that are the same connected together. Here we have molecules of a compound. We have a central atom and three other atoms that are the same as each other but different than this one. And here we have a mixture of two elements and a compound. So I would say all of these represent a gaseous state of matter based on the space in between. So here is an example of likely a solid. You see that it has a definite shape. The atoms are very arranged. So this is likely a crystalline solid, all the same element. This is a model of likely liquid water, H2O. This is a solid. It's definitely a solid, and it contains two different elements. So this could be a representation of what brass is like, in which we have copper atoms and zinc atoms. And then here is a heterogeneous mixture. You can see these individual chunks, likely this brass, chunks of brass in some water. And that is the end of this presentation. I know it went kind of fast, and I know that it was better than what I did during my synchronous learning experience for my students during this COVID pandemic. So thanks for watching.